Chapter 4, Worksheet number 4, second part. Draw the velocity and acceleration vectors for the following objects. So velocity first. Car moving to the right and speeding up. So the car is moving to the right. It is speeding up, therefore the acceleration is in the same direction as the velocity vector. A bus moving to the right, the velocity is to the right, and slowing down. If it's slowing down, then the acceleration is opposite to the velocity vector. A block sliding to the left, so the velocity is to the left. Slowed down by friction. If it's slowing down, the acceleration is opposite to the velocity vector. A bike moving to the left, so velocity vector is like this, and speeding up, so the acceleration should be in the same direction as the velocity vector. A ball was thrown in the air and is moving upward. So the ball was thrown. That was a long time ago. That's when the acceleration was up. But now there is no more hand touching the ball, so there is no more upward force. It is now in free fall. It is now left by itself, and the only force acting on it is the downward force of planet Earth, the force of gravity. The ball is moving upward, therefore velocity is up. And you know that the ball is slowing down, therefore acceleration is down. You can check that your acceleration and your net force are in the same direction. A rocket with an upward acceleration of 3g. So they tell you that acceleration is up, and from the diagram you can tell that velocity is up, and you can also look at the thrust. That's an indication that the rocket is moving upward. And we can tell from the diagram that it is speeding up. A stone is falling down, so this is again a case of free fall, because we assume that a stone is not very much affected by air drag. A stone is moving down. The acceleration is the acceleration due to gravity, it's down. So that object is speeding up. The last one is a plastic toy thrown into a swimming pool. And they tell you the toy is slightly less dense than water. That means that the toy will eventually float. But when you just throw the object into the water, usually it goes down like this. And it slows down. So the acceleration is up. Then later on, it's going to stop, and then it's going to reverse its direction, and it's going to move upward. And eventually it will float like this.